Good morning, friends.
Good morning.
Yeah, let's begin our session. We have seen what the definition of the pod yesterday, and we discussed that every Kubernetes definition file will consist of 4 top level elements. One is API version, another one is kind. Based on this kind, this API version will be there. Metadata, it has some additional data. We will learn few other things like labels and how to specify the namespace. Then we have spec, stands for specification. It will contain containers and other specifications will also be there. Slowly we will be learning them. This is just a single pod. We can't have multiple instances with the kind of pod. What if I want to have multiple instances? For that, we have another Kubernetes object that is called replication controller. Okay, so now let me copy this definition. I want to create some file. The name of the file is your wish. It is nothing to do with the name of the replication controller or anything. The file name can be of anything irrespective of the properties of that file. Control V. Okay, so we have API version, kind, metadata, spec. Right now, kind is replication controller. API version for that is V1. Name of the replication controller I want to give as name my app RC. And labels. Labels means this also comes under metadata, some extra information about this replication controller called my app RC. So labels, this is key. Inside key, we have key value pairs, that is app equals to my app, type equals to front end. This is some additional description. Okay, something like this belongs to front end application, whatever we are going to deploy. So that can be specified in this metadata like this. Okay, so now in spec, earlier we have in pod, we have what? Container section. But in this replication controller, we have a property called template. We have a property called what? Template. This template is of what template it is? This template is pod template. Pod template. That means, let's say, so we have the template property. Replication control have the capability to create multiple replicas for us. Okay, and multiple replicas of which pod? That pod we will define inside the template. Okay, this is the pod definition. Pod definition. So if I come here, what is the pod? This thing will be placed here. This thing will be. So now let's write that. Okay, so template we know. So we have to remove this kind and API version now. Just we have to write this thing in the pod definition. In template is nothing but the pod definition here. So metadata, I want to name that as, let's name this as what? Let's name this as my pod. Okay, let's name that as my pod. And I don't want to give the labels. Okay, labels. Okay. Without labels it won't work. And let's give this as this one, nginx, and metadata. Inside metadata we have what? We have name and we have spec. Metadata and spec. So in spec we have containers and name of the container nginx content image is nginx. Now in spec another property we have replicas. How many replicas you want? I want to have 3 replicas. Now let's do this. kubectl apply here invalid. Okay, so why it is invalid? Another is asking for. Okay, so why it is invalid is, now if I come here, spec we have to specify the labels here. Using that labels, okay, the replication controller will select the pod definition. Otherwise, replication controller won't select. Now let's give the labels. Okay, in metadata, we have the label section. These labels are for pod. Okay, these labels are for this replication controller. So in these labels, now let's give something like let's give something like a name equals not name. Some give something like server equals to nginx server. Let's give something like this, and let's use this up to this, and now see what will happen. Okay, it got created. Now how to check replication controller? That we have with replication controller. We have this command. Okay, but we can also use RC, replication controller, in short. So if you see, as a part of this, we have 3 pods. How to see the pods? kubectl get pods. So those 3 pods are running. So here in replication controller, in pod definition, we have to specify the labels, because using these labels, this replication will bind, replication controller will bind, and it will create the pods whenever a pod is down. Now let's do one thing. The job of this replication controller is, it will ensure that always the desired number of replicas are always up and running. So if that is case, now let me try to delete a pod. Okay, so how these pods are named? They are named something like the replication controller name, and some alphanumeric has been attached. Okay, this is. Now let me delete a pod. Let me delete this pod and see the pods. What happened? Because our desired replicas is 3, once the pod is terminated by any reason, a new pod is being created in its place with a new name. With new name, we have deleted pod with H79. Okay, so that is that new container won't be created with that name. Some random name will be given to this pod. This is how replication controller will work. Okay, that is. After that, so how to get this? First, we can create. You can forget about the create. You can use just apply command. Create command will be used. Once if this is not created initially, then we can use the create. Apply command will be used to apply the changes to the existing file. Okay, and even if you don't create initially, also we can use directory apply. That will also create the object. So to get the replication controller, and to get RC, to describe replication controller, to delete replication controller, those are the commands. Okay, so kubectl get RC, kubectl describe RC my app RC. This is a command. Okay, so this is how these pods are being created. You can see in the events. Then we have another object called replica set. Replica set. So if we use, let me try to use kubectl scale replica set, my app replica set. Okay, my app scale, and let's give hyphen replicas equals to how much I want to have. Replicas equals to, let's say 5, and the scale replica set, what is it? My app RC. Okay, so we can scale them with this command. Replication controller, this is okay, that is fine, that we can do here also. Now let's delete this kubectl get rc, kubectl delete rc my app rc. This is delete. Now let's see another one, replica set. So here the API version is v1. Here it will be app/v1. It is some advanced version of the replication controller, and the kind is replica set here. Now here the difference is, in this we have specified the replicas and the template. But in this, apart from template and replicas, we have another property called selector. This is somewhat confusing. So you see here, this is what, let's say this file itself we will use. Okay, now the difference is the version will be app/v1 and kind is replica set. So apart from this template and replicas, we have a property here called selector. Okay, in selector, what we do is we will select the pods. Okay, in replication controller, by default these pods will be created using these labels. Okay, replication controller will select this template using this labels, and with that the desired number of replicas were created. In replica set, in addition, we have a selector field. Okay, in selector, what you want to select? I want to select this pod definition. Okay, I have to select that. How to select that? For that, we have a property called selector, and inside that, match labels. Match labels. So in match labels, so what is the pod template that you want to match? That is server equals to nginx server. Okay, server equals to server : nginx server. Now let's create this, and before applying this, I want to do one more thing. I want to use the same labels here as well. Here we are using labels. Now let's apply this pod. This is a simple pod. Let's apply this. kubectl.
Sir, what is label? Sorry,
Label is nothing but some additional information. We are labeled. For example, for fruits also we will see label for any fruits that we are. So that label, some additional information we are giving. Okay. So that information we will use to select the particular pod. Got it? So like that, for example, meaningfully we are describing this. So once we see the label here, we will understand, oh, this is related to some front end, not back end, not a database. So that kind of additional information we will be giving to the particular Kubernetes object using labels.
So you gave this label in 5, 6, 7 line. Again, why you gave in 12 and 13 line? Because it is
These
there, right?
these label, yeah, these labels are for replica set. These labels are for pod. Okay, so
Mhm.
replica set will create 3 pods, which are the pod definition is this.
So for all those 3 labels will be Nginx server only or Nginx
Yes,
server
yes,
1,
this one
2,
only. This one only.
same.
Yeah.
That means if you mention this Nginx server, then all
Hmm.
those 3 will come up.
Yes, yes, yes.
Ah, okay.
Okay. So now let's apply this pod, and here the labels are server is Nginx server. This is how we are giving this labels.
And why you are changing that API version apps/v1?
That is how they have given. Okay, for replica set, this is
Okay.
another one. For this is okay.
For replica set, okay.
Yeah, yeah. So now kubectl get pods. So the pod has been created. Okay, remember that we have given this label to this pod. Now let's come to this replica set. Replica set. Here, what I'm doing is in replica set we have another property called selector. So it will create these 3 pods. Okay, which pods it will create? It will create the pods which are having this label. Okay, now this is having this label. Now let's do that. Okay, so this pod will be created, and this pod will be having 3 replicas. Okay, 3 replicas of this pod will be created using this. Now let's apply that. If I apply this and see what will happen. So how many are created? This is our earlier one. How many are created? Only 2 are created, but we have specified 3. That is fine. But in selector, what we said is, I want to have 3 replicas. 3 replicas.
Sir, where did you
Okay.
give name here? My app RC. This one you gave already?
Yes, this is.
Okay, sorry. Thank you.
Okay. So I want to have 3 replicas. That is fine. From where I have to get the 3 replicas? I will get this from this template, and I want to have 3 replicas of pods which are having this label. And a pod with this label is already running in our cluster. So one is already there. Total we want to have 3. How many have to be created? 2 have to be created. So those 2 will be created, and from which they should have some pod definition. From which definition it will be created? It will be created from this pod definition. Okay.
I did not realize the purpose of selector, because replicas are getting created even if we are just mentioning up to replicas.
That is for
Then
replication controller.
hmm,
That is for replication controller. We don't need to specify this. 3 replicas will be created from the same definition. But coming to replica set, what is happening is, here we will have the 3 pods. Okay, and the 3 pods will be created with this definition. That is fine. But if any pod is already running with this label, that will also be taken into consideration. So this pod is already running, and this is having the label, and that label only we are selecting. That pod will be taken into consideration, and in total we want to have 3. So 2 more have to be created. Those 2 pods will be created from this definition.
you mean to say if we are not mentioning the selector, and even if there are 2
No, we have to mention the selector in replica set.
Okay, no. My question is, like, if already 2 pods are running, and if you have not given the selector, then total 5 replicas will be created.
No,
Likewise.
no. Selector we should specify, otherwise it will fail. The definition will fail. It will say that it's wrong. Got it? So let me do that for you. kubectl delete yeah. Okay. Now what happened is, now this pod became a part of this replica set. So now what will happen is, now let's delete this pod. Now let's delete this pod. kubectl delete for my engineer. If I delete this part, what will happen? This replica set has to ensure that always 3 pods are up and running for us. So now if I delete this pod, what will happen? Another pod will be created in its place. Now the pod will be named like this. Okay. This is a, now what you said, if you don't give the selector, what will happen? So what I am doing, let
So,
me
Laxman, when you remove this pod, right, and you're recreating it, right? So for example, this Nginx application only, if I am accessing that website and my request went to this server SX2CH, and you are removing this, so so still that my transaction will work.
This is stateless application, right? Okay, once your transaction is over, it will be terminated. Okay, so this is a stateless application. Okay, for stateful application we have different thing that will be there. We will be seeing that as well. Okay. Okay. So once this is terminated, your request will be routed to another one. In service, we will see that request will be load balanced using the service object internally. Now kubectl get replica set or rs. kubectl delete rs my app rc. Okay, that is rc we have named. So now let's apply this. So it will fail. Why it will fail? Because this property should be there for the replica set, and that should not be there for replication controller. Okay. So if I uncomment this, it will work. And now this time, because we don't have any pod already running, it will create 3 pods afresh. Okay. That is. Then so we can scale them up, we can scale them down using this. Okay, that is fine. But in real time in production, what we will use the horizontal pod auto scaler. We will see that going forward, just to be aware. So these are the some of the commands that are associated with this. So once we have the higher number, then it will be called as scaling up. And after that, if we specify the lower number, then that will be scaling down. That will happen. Now in this, what is happening is, once if we want to update the image, what will happen? All the containers will be deleted, and all the containers will be created. So when they are deleted during updation, if they are deleted, there is downtime that is not desired. So for that, to overcome that problem, we have another Kubernetes object called deployments. So it will also be useful for creating multiple replicas. If you see, the definition of the deployment is same as that of replica set, except that kind is deployment. Everything is same. Here the kind is deployment. But the property here is, you can have the rolling updates feature in deployment. These replicas will be created, okay, by the replication controller. Once we deploy this, behind the scene, replication controller will be working to get the to give these 3 replicas. Okay, but if we use this deployment, what will happen is, there is a feature of rolling updates. Okay, so rolling update in the sense I will explain you. So now
So
let's
this kind parameter is mentioning what kind of pods will get created, like
what kind of
whatever
Kubernetes object.
objects. Okay.
Okay, so as a part of this kind, ultimately pods will be created as a part of deployment. We have another kinds also like service and other things also we have. Okay, we will be learning them as well. So kubectl get rc. Let's see, do we have any replication controllers? We don't have. Do we have any replica sets? We don't have. Do we have any deployments? We don't have. Now let's deploy this. Okay, so before understanding that, now let's understand about rolling update. Rolling update means let's say we have a deployment. Okay, so as a part of this deployment, let's say 5 pods are running. This is deployment. As a part of this, let's say 5 pods are running. 1, 2, this is 3, okay, this is 4, this is 5. Now let's assume that 1 minute, friends. In this deployment, 5 pods are running. Now let's assume that in this, when the containers were running, definitely image will be there. Let's say that image is nginx, and it will be like what? So it is latest. Latest is image is running, and let's say this is some version 1. Now after that, here also the same thing will be there. This image will be running. So in all these cases, the same image will be running here as well. Now developers have now developed some feature, and now the Docker image. How do we create the Docker image? From Docker file we will create. In Docker file we will take the source code of the application using copy. Okay, after that we will execute the commands using run, cmd and all. We have seen that. So now let's say they have developed a new feature, and now let's say the image name is what? nginx, some another version nginx, some let's say version 1.0 or 2.0, let's say. Okay, this is the image they have developed afresh. So here I want to update this. This is already running. I want to have this. There are two approaches to do this. One is recreate. One is recreate. Another thing is, another one is rolling update. In recreate, when we modify the image of the deployment, all the pods will be down. All the pods will be deleted. All the pods will be deleted at once, and new pods will be created with the new image. And if this is the case, when they are deleted, there is downtime. Application won't be accessible, right? So how to overcome that? For that, we have another strategy called rolling update. In this, what will happen is, first, let's say this is the deployment. First, new pod with this image will be created. New pod with this image will be created. After that, once this is created, this will be deleted. Then now, so what will happen? Now total how many we have? 5 replicas that are desired state we have. Now next what will happen? Next another pod will be created. Okay, with this image. With this image, another pod will be created. After that, this will be done. So now 5 pods are there and there is no downtime because the application is running in 3 other instances, old version, and 2 instances, new version. Now, like that, next will be created with the new image. It will be done. After that, then again, this will be created with the new image will be there in this, and this old pod will be terminated. And same for the last one as well. This will be created, and here this will be the new image. So without having any downtime, we're able to successfully update the application. So this is, so by default, if we don't specify the strategy, it will be rolling update. Now let's apply this. Now I want to have 3 things, 3 pods, and now let's apply this definition kubectl. Now let's rename this first, so that you won't be confused. You can name anyway. Okay, this one. Let me name this as deployment itself. That is fine. Now let's apply this. kubectl get deploy or get deployments or get deployment. Anything will work. Now the deployment, we have given this name. Okay, there is no need to worry about that. Now kubectl get pods, we have 3 pods. Then now if I search for kubectl get replication controller, sorry, kubectl get replica set. Okay, so as a part of this deployment, a replica set has been created. So what is the job of the replica set? To ensure that always desired number of pods are up and running. If I go and delete a pod, kubectl delete pod, if I delete this, what will happen? New pod will be created in its place by the replica set. Okay, so this is. Now what I will do is, now let's update that. Now let's update the image. So now before going to that, now let's get the configuration of that kubectl. Now get deploy, the deployment name is my app rc oml. And let's copy it. Now if you see this, see strategy is rolling update, max search and maximum unavailable. Maximum unavailable means, let's say we have 12 pods. Okay, 25% of the 12 is what? 3. Okay, so 3 pods will be updated at a time. So that is max search means and 3 will be created first, and after that the 3 will be updated, and the type is rolling update. So if you put strategy, inside strategy we can put what? Recreate. So in that these properties won't be there. If you use recreate, all the pods will be down first and they will be created at a time, that thing. So now what I will do is, I want to update this And before that, I want to scale this up. How to scale this up? kubectl scale deployment. Okay, my app RC is the deployment name. How many replicas I want? I want to have, let's say, 5 replicas.
You are already created 3 replicas, right? Again, why into is it you are just showing how to scale? Or?
Yeah, so let's say that there is an increase in traffic. Anyway, we don't scale this manually. We will use auto scale apply. For that, we have another Kubernetes object called horizontal pod auto scaler. Just I want to just show you this command. That's it. Okay.
That means first 3 pods will be created when you use.
First 3 will be already there. They are already running, right?
On top of that, another 5 will be created.
No. Only 2 will be created and total will be 5. Okay.
Sir, is it overriding?
No, not overriding. The 3 will be there. Those are already created, and the new two new pods will be created, and it's something like total thing.
Okay, we are giving desired state.
Desired state. Yes.
Okay.
Yes, that is. So if you want to scale this down and just simply put the lower.
After saying the timing only, it will come to right. Generally, it is 2 minutes. Right?
Yes. And we can describe that as well. Now, if I go to description of the deployment, describe deploy my app RC.
This is we just seeing for the understanding. This all will things will done automatically by Kubernetes right now.
Yes. Okay. Then kubectl red pods total 5 will be there. So if you want to scale them down, in that case we have to apply some lower number. That's it. And 3 will be deleted. Only that 2 will be there. Okay. This is now what we do is I want to update the image. Okay. So for that we are using Nginx, right? So now let's go to Nginx another version. Somewhere I have written that we are taking latest Nginx. So now let's use 1.18. So initially Nginx latest is running. Now I want to update this to this one. With what command I can do? kubectl set image for deployment. What's the deployment name? myapp.rc, and I want to replace this image with this. Okay. Now let's do that here. This is our deployment name. kubectl set image. Okay. For which deployment? myapp.rc set image deployment. Okay, myapp.rc. So in case of Nginx, I want to put Nginx 1.18. Okay, so now I want to do this. Before that, let me copy this first.
So if it is in place of 1.18, then we will mention like Nginx colon 1.18 equal to.
Yes.
Like that.
Now,
Okay.
yes, let me scale them to 6. Okay, so now I want to open and the terminal here. Okay, so now here what I will do is I will just watch the pods. Open watch. Okay, so now once the status is updated here, that will be shown there. Now I will apply this command now. The kubectl set image deployment. Unable to find a container named NGINX.
I think Nginx colon latest we need to give.
No, by default, what it is saying is, it is saying container. Do we need to container here? I don't think so. Let's browse that. Oh, it is container name, not the image name. It's a container name. So what's the container name in our case? The container name is Nginx container. Okay. So here, this is how we are specifying here. That is fine. So for that container image, we want to update. So what is happening here? See, so first the container is being terminated and the new thing is trying to be created. So once, see, this is another thing, and this is not able to show that properly. So containers are being created, some are running, some are being terminated. So like that, we are getting those things. Now, if I just use get pods, all the containers won't be, all the pods won't be terminated. One after the other will be terminated after getting the new thing. So always during the update, it will always ensure that the design number of pods are always up and running without to avoid the downtime. So this is, if I go to the events in the sense, if I go to the description of that, it will get deployment, describe deployment, my app RC. This is the deployment name. See, this is the earlier. So now what happened? Scaled up replica set to 2. 68 seconds ago, scaled up replica set my app to 2. Scaled up to 3. Scaled up to 3. Okay, that's fine. After that, we want to have 5. Then 6. Then we got how many replicas? 2. Why it will be 2?
It is terminating 2 and creating 2.
No, not like that. Whatever the said, this thing will be opening. This thing will be happening. But here, replica set, so scaling up to 2. Always 6 are running. Now it is creating 2 means 4 are down. So no, that won't happen.
Maybe it is not in sequence.
What?
Is it in sequence?
No, I don't think so. That's what this is the latest one. This is 68.
Within these seconds.
So this yes, yeah, within milliseconds it is happening. So it may be coming first. Okay. That way it will happen. So anyways, or it will be scaling down. Why the earlier replica set will, yeah, this is the new replica set, friends. Okay. So this will be the new one will be created. New parts will be created. And that will become what? A new replica set. If I go and check here, kubectl get a replica set. So we have 2 replica sets. Okay. So the first one, this is one thing, and this is one thing. This is created earlier. So this will be first. This will be scaled up. Why it will be scaled up? First, it will be having 0, 1. So it will be having scaled up to 2. Then after that, after the once it is come, then this will be scaled down. It will be scaled down to what? One pod will be terminated, and now the new pod will be running. So this way it will be happening, and this will be the The old one will, new one will be scaled up, old one will be scaled down. So finally we will be having the desired one. So finally this will be scaled down to 0. This is, and this will be scaled up 6. We will be having total 6 here. Now if I see kubectl get pods, we will be having 6 replicas. 1, 2, 3, 4, 5. This is how it will be happening. So with this we understood that as a part of the deployment, behind the scene replica set will be there to scale up and scale down. And if one pod is terminated, delete pod, and in its place new pod will be created by whom? Replica set. Okay, now let's see some of the commands that are there here. We can see the history. We can see the rollout history. See rollout history. The deployment name is my app RC. Okay, revision 1 and revision 2. If you want to, for example, let's say that we have updated the application, but we observe that the application is not good, or the feature that they have developed is not working properly. So we should have a mechanism to roll back the changes. Before that, I will show you the what image is being running in the container, what image is being used in the container. For that, get pod. Let's get some pod here. Get pod -o-aml. AML spelling is wrong. So this is the image running. Now let's say this updated application is not running as expected, or the features are not developed fully. So there is a need for going back to the previous state. For that, we have a command called now rollout undo. Rollout undo. I want to undo the rollout. What is it? My app RC. If I do this, so the thing will be rolled back. The rollback will also be happening the same way the rolling update is happening one by one. They will be terminated. So finally we got it. kubectl describe for get for, let's say describe pod. In description also we will be getting, and we will be getting the image. If you see, so this image is being used here. So if you want to get the rollout status, you can get that through this command. Successfully rolled out. This is the status. This we have seen. This is fine. Okay, if you scale down, you can do that way. And if you want to interact with the pod, we know how to interact with it. Okay, so anyway, the same thing will be there. kubectl as the type T. The pod name we have to give and dash. So we will be entering into the terminal of the container. This is exit. And if you want to delete the object which are created using this definition, okay, now see what will happen. kubectl delete F. Now observe what will happen. kubectl get deploy. Okay, so this deployment, which is called this one, will be deleted. So even if we have 3 pods, but this deployment is containing 5 pods, right? 6 pods. So everything will be vanished. That is. Now let's go to another object, another thing called daemon set. Okay, somewhere the order is missed. Okay, so now we don't need to go there. Daemon set. So till now we have seen pod, replication controller, replica set, and deployment. So deployment have the options, features of rolling update and rollbacks, and these things are not possible with the other object. We have another thing called a daemon set. Till now, in this deployment of the replica set, we are specifying the number of replicas. Okay, so anyway, we will automate that later using horizontal pod autoscaler, that is HPA. But what if we want to have a replica on every node? On every node, I want to have a replica. This is our Kubernetes cluster. In this cluster, let's say we have 3 nodes. Forget about the control plane. Control plane won't carry the load. No pods will be running on the control plane. And these nodes will be having the pods running on them. In deployment, if you specify 3 pods, the 3 pods may be created one here, one here, one here. Also, if the load on this is increased, there are no sufficient resources and resources in this, the pod may be created here as well. That pod may be created here as or else here. Okay, so in this case, we have only pods on these 2 nodes. But in some cases, let's say if you want to run some logging application to get the logs from the node and the pods that are running on that. In that case, we need to have a replica on every node. If the new nodes are added with the auto scaling, Kubernetes auto scaling, node auto scaling, and in future, if that node is added, we want to get the replica on this node as well. Okay, and once this is deleted, I want to delete this pod. Okay, I want to have a single replica on all the nodes. For that, we have an object called daemon set. So daemon set will create a pod, a replica on every node of the Kubernetes cluster. So how to define that? So the daemon set definition is also very simple. Okay. So
sir, can you on the paint, can you please show it like replica, like node, pods, replica, how it will be?
Yeah, pod itself is replica.
Okay. Then
we have 3 nodes, right? So in deployment, let me do this. In deployment,
yeah, there is a little bit confusion to me also. Sorry.
What I'm telling is, okay, that's fine. Till now, let's say we have a deployment or the replica set. In that case, we will specify how many replicas we want. We want to have 3 replicas or 2 replicas. The 2 will be created, one on here, one on here.
Yes, yes. Okay.
And there is no guarantee that it will be created on this. That may be created here itself. Correct. Or it may be created here as well. And if you want to have 5 replicas, so or 5 replicas, one on here, one on here, one on here, one on here. That will be distributed. But I don't want that. I want to have a replica on every node. Got my point, right?
Okay. Irrespective of
I don't specify the number of replicas. I don't mind that. If a node is there in my cluster, I want to have a replica running on that node.
Replica means at least
Replica
one
means-
pod should be running.
Yeah, not at least, exactly one pod should be running on every node.
Okay, that you are calling as replica. Okay.
Yeah, the pod I'm calling just as
Yeah.
a replica.
Okay.
Okay. So how to achieve that kind of state? For that we have an object called daemon set. We have so this daemon set will be used in some monitoring agents, monitoring kind of agents where we want to have a replica on every node for that. So now if we apply this, how to make this as a daemon set? So very simple. So we don't mention this replica set, and here it will be daemon set.
All these comments you are running on that AWS.
Yeah,
cluster.
EKS cluster only. Okay. I have connected to EKS. I have shown that, right? How to create that.
Yes, yes. During first day you showed.
Yes, yes. So this is so, and here we don't specify the replicas. We should not. Okay, that property won't be supported in daemon set. Okay, so exactly same as a deployment, but we don't have the replica set, and we have to change the kind from deployment to daemon set. So if I do this, first let's see what are the things that are running here. There is nothing running here, and I did not specify any replicas here. And if I see how many nodes are there in my cluster, 2 nodes are there. So as for my explanation, we should get how many pods? We should get 2 pods, and those 2 pods should be running one on every node. Okay, now let's apply this.
If you don't mention replicas, then how come it will scale? Because
That is what daemon set is all about. We want to have a pod, a replica on every node.
correct, but if here 3 nodes,
3 nodes are there. If you
3
have
machines
10
are
nodes,
there.
10 will be created.
No, if there are 5 pods to be created.
Okay, why do we want to create 5 pods? If you want to create that, you have to use deployment. But here the situation is you want to run some monitoring agent. And for that, you should have what? We should have a monitoring agent running on every node. If this is running on only 2 nodes, if it is not running on another node, how do we get the metrics of this node? Who won't be? So for that, I want to have that agent running on every node. So for that, I have to give this daemon set.
You mean to say like pods are different, replica set are different, and this daemon is different for monitoring only.
Yeah. So if your requirement is such that a replica has to be created on every node, then you have to go for the daemon set. So if you see get pods -o wide, see a replica is running on every node. Okay, so for example, tomorrow if you are scaling up your cluster, let's say you have added 3 more nodes, automatically 3 replicas will be created, 1 on each node. Got it? Why so much confusion? Very simple. Among all daemon set is very simple. Okay, right? That's it for today, friends. Let's meet tomorrow. If you have any doubts in this daemon set, you can ask me. No worries. In deployment, we will specify the number of replicas, and in that case, we don't worry where those replicas are running. That 5 replicas may be running on single node, and 2 nodes or 3 nodes, we don't worry about that. But in some cases, let's say monitoring and logging agent, we should run the monitoring agent on every node. So how to get that? How to get a replica on every node? Daemon set is the one. Tomorrow, if the nodes are being increased, that replica will be created on every new node. That is.
And there will be no case where like nodes are 3 and we need to 5 replica set. Likewise, no, na?
Yes, we don't
Because,
mention that. How many nodes are there? Those many number of replicas will be created.
That's it.
Okay. And one thing is that you people may be running this EKS cluster, and if you want to delete the, if you don't delete this cluster, you will be heavily billed for that. So how to delete that? First, we have to delete the node group. First, if you delete this cluster, it won't be deleted. And some people may delete only the EC2 instances, only the nodes by going to EC2. If you go to EC2, our nodes are running there. Okay, nodes are running there. And what you do is, you will just delete these 2 nodes. Okay, you should not do that. So if you delete these 2 nodes, what will happen? These 2 nodes will be created again, because when we are creating the node group, we will specify that the desired number is 2. So these 2 numbers will be already, they will be always up and running. So you have to go to cluster.
Sir, node group means EKS without node group, is it chargeable, sir?
Yeah, without node group, EKS is also chargeable. If you add node groups, you will be billed for that EC2 instances and the storage that is attached to them. Without node groups also, your EKS cluster, empty EKS cluster will also be chargeable. Why? Because this control plane is running on some servers. So that control plane,
Okay.
yes, so that will be built. So first we have to terminate the node group. Confirm that here. And after 2 or 3 minutes, when this node group is completely terminated, at least it will take 3 to 4 minutes. After that only you can able to delete this. So now even if you try to delete this, it will tell that node group termination is in process or something. It will
take 5 minutes, at least.
Yes. Okay, at least it will take 5 minutes. After that you have to delete this. Okay, and yeah, that's it. Let's meet tomorrow, friends.
Sir, have you shared class notes on Google?
It is shared, I think.
It is shared already.
And
And those who have subscribed for the Kubernetes have to get the Google Drive link from the admins. Have you got that the drive link for you, the new people?
For video, I got. For notes, I have not got.
Notes you got
in that
Google Drive, right?
in that folder itself.
Okay, I have to create that folder, but they have to share that link with me. Once that is done, I will do that by end of the day.
Okay, so those who said like it is there, it is for Docker and plus Kubernetes or just Kubernetes?
No, if you opted for only Kubernetes, they will be.
Yeah. I'm asking for Kubernetes only.
Okay, only Kubernetes. No. For Docker and Kubernetes, the link will be shared and you will be given some different folder.
Yeah, I can see a Kubernetes folder access I have, but there is no file under that.
Okay, I have to create a folder in that. They have shared that link with me. I will check my mail and I will contact them. By end of the day, I will upload the notes in that.
Sure. Thank
you. Okay, friends, you can leave. We can leave.
Good day, sir. Good day. Thank you, sir.
Good day. Bye.